Welcome to YQ Academy Exceptions and Exception Handling Java Interview Questions and Answers. 1. Explain a situation where finally block will not be executed. 1. System.exit opening bracket closing bracket or fatal errors. If the Java program terminates abruptly due to a call to system.exit opening bracket closing bracket or encounters a fatal error, such as a JVM crash, the finally block will not have a chance to execute. These situations forcefully terminate the program, bypassing any remaining code, including the finally block. 2. Infinite loop or endless execution. If the execution flow enters into an infinite loop or enters into an endless execution scenario that prevents the code from reaching the finally block, the finally block will not be executed. This can happen if there is an infinite loop before the try block, within the try block itself, or after the tree catch construct. 3. Sudden power loss or system failure. In rare cases, if there is a sudden power loss, hardware failure, or any other catastrophic event that causes the system to shut down abruptly, the finally block may not get a chance to execute. These situations are unpredictable and beyond the control of the Java program. 2. Can we use catch statement for checked exceptions? Yes. The catch statement in Java is primarily used to catch and handle checked exceptions. Checked exceptions are exceptions that are checked at compile time, meaning the compiler enforces the handling of these exceptions either by using a catch block or by declaring the exception to be thrown in the method signature. 3. What are user-defined exceptions? User-defined exceptions, also known as custom exceptions, are exceptions that are created by the user to represent specific exceptional conditions in a Java program. While Java provides a set of predefined exceptions, such as null pointer exception or IR exception, sometimes it is necessary to define custom exceptions that are tailored to the specific needs of an application. To create a user-defined exception in Java, you need to define a new class that extends either exception checked exception or runtime exception unchecked exception or one of their subclasses. By extending these classes, the custom exception inherits their behavior and characteristics, allowing you to define additional properties and methods as needed. Example 4. Can we rethrow the same exception from catch handler? Yes, it is possible to rethrow the same exception from a catch handler in Java. Rethrowing an exception allows you to propagate the exception to an outer catch block or method, enabling it to be handled or processed at a higher level. 5. Can try statements be nested in Java? Yes, try statements can be nested in Java. This means you can have one try block inside another try block. This feature allows for more fine-grained exception handling and the ability to handle different exceptions in different ways. Here's an example of nested try statements. 6. Explain the importance of throwable class and its methods. The throwable class in Java is the root class of all exceptions and errors. It is an important class in the Java exception hierarchy and provides a set of methods that are commonly used for exception handling and error reporting. Some of the important methods provided by the throwable class are: 1. getMessage. This method returns a detailed message about the exception or error. It provides information about the cause or nature of the exception, which can be useful for debugging and error reporting. 2. Print stack trace. This method prints the stack trace of the exception or error to the standard error stream. The stack trace shows the sequence of method calls that led to the exception, including the class names, method names, and line numbers. It is helpful in diagnosing the cause and location of the exception. 3. getCause. This method returns the cause of the exception, which is another throwable object that represents the underlying reason for the exception. It is typically used in conjunction with chained exceptions, where one exception is caused by another. 4. toString. This method returns a string representation of the exception or error. It typically includes the class name, the detail message, and other relevant information. 7. Explain when ClassNotFoundException will be raised. 1. Class not found. When the specified class name passed to class for name or class loader. Load class does not exist in the class path or is not accessible by the class loader. This can happen if the class name is misspelt, the class file is not present in the class path, or the class is in a different package or module that is not visible to the class loader. 2. Class dependency. When the specified class depends on other classes or resources that are missing or not available in the class path. Java classes often have dependencies on other classes, and if any of these dependencies are missing, the ClassNotFoundException can be raised. 3. Class loader issues. When there are issues with the class loader itself, such as a malfunctioning or misconfigured class loader, which prevents it from loading the class. This can happen if the class loader is unable to locate the class files or if there are conflicts or inconsistencies in the class loading process. 8. Explain when NoClassDefFoundError will be raised. The NoClassDefFoundError is a type of error in Java that is raised when the Java Virtual Machine JVM or the class loader is unable to find the definition of a class at runtime, even though the class was available during the compilation phase. The NoClassDefFoundError is typically raised in the following situations. 1. Class definition not found. When the JVM or class loader is unable to find the definition of a class that was referenced by another class at runtime. This can occur if the class file was available during compilation but is missing or inaccessible during runtime. 2. Class path issues. When the class path is not correctly set or configured, preventing the JVM or class loader from locating the necessary class files. This can happen if the required class files are not included in the class path or if there are conflicts or inconsistencies in the class path configuration. 3. Dependency issues. When a class depends on other classes or resources that are missing or not available in the class path. If any of these dependent classes or resources are not found, the NoClassDefFoundError can be raised. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until another time, goodbye.